Audio check. 1, 2, 3. Audio check. 1, 2, 3. All right, we're good. We're live. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy, where we are today building a compiler from scratch with no dependencies. The Monday through Thursday is usually game with no game engine, and Fridays is like our day off to work on whatever without regard for delivering anything. So we're building a compiler from scratch, no dependencies, and we're doing it the hard way. We're building a Tokenizer Generator, which is a much more complex problem than building a tokenizer. The tokenizer is actually very trivial. You should try to build one yourself. It's just a loop through every character and making decisions as you go through each character. It's not too hard. Then only work on a Tokenizer Generator if you're really interested in like state machines, like DFA, NFA transformations, and so forth. So in that way, we're doing this all wrong. Like, this is not an efficient way to build a compiler, to build your own Tokenizer Generator from scratch. But it's even worse than that, because we're not only building the Tokenizer Generator, we're building it so that it generates every combination of performance impacting choices I decide. So, for example, let's see here. File reading. We can do a system level call, a library level call, or we can do a modern C++ class-based call to read a file. We implement it all three ways, and you use a pound to find and choose which one your tokenizer actually uses. So we're generating something like 120 different combinations of code paths, which overlap and interact in strange and mysterious ways. And one of those choices is how we dispatch our DFA state. When you get a character, you decide what state to go to, and then when you get the next character, you decide what state to go to. So that's dispatching your DFA state, your deterministic finite autonomous state. And right now, we're doing that three different ways. We're doing it with a switch statement, so there's a little enumeration of possible states. You get your character, it sets the enumeration, and then back at the top of the loop, it uses a switch statement to decide which state to go to next. We also have a function array, a function pointer array. So this enumeration that's used here instead is used to look up an index into an array of function pointers. There is a lot of misunderstanding in modern programmers about what's more efficient. And so what we're going to do is we're going to measure it all the ways and see what impact, if any, our choices have on our performance. Lastly, we just have a function pointer where instead of setting an enumerated value of states, we just set the next function that it points to. But the one we have not done is the no function states, where in these three options, every state is defined by a function that we enter, and it checks, different character values and makes decisions based on that. But we could do it so that all of the state is managed within a single function. I use gotos and labels to jump from state to state. And that one's been on the back burner for a long time, because with all these other combinations of things, we needed testing that would test every build combination reasonably and give us some idea that what we're doing is not breaking other combinations. So if I were to make a change to a helper function, well, maybe I didn't make that change in helper macros. This automated testing would discover that, or vice versa. Or if we made a change to batch processing versus lazy processing, that can have impact on different things. So, but what we have not done is goto dispatching. And gotos are evil, blah blah blah. I don't actually believe that, but we're going to actually use and abuse gotos. In fact, it's going to be kind of impressive, some of the cool things we can do with gotos. The first order isn't that bad, but by the time I get to the parser generator, we'll do some things that only GCC can do and no other C++ compiler can. So it'll be fun. I'm trying to decide how many of these kinds of things we also do in the parser generator. I have specific ideas about some cool things to try with the tokenizer generator. For the parser generator, I'm probably just going to do an LALR parser generator, and I don't have anything new to add other than testing some combinations of behavioral things. But this is a really bad way to build a product. This is a good way to explore code and its behavior, though. So this is what we're going to start on today, and we're going to narrow the scope a little bit. So let's go to our journal. 2024, 11, 22. We're going to start go to state dispatch in batch processing mode. Okay. This goto is going to make some very interesting things happen. Let's go look at one, I guess. VV test, VV test parser. Down here, every state is a function. That's not going to be true anymore. All of this code will have to live inside the same function. So this next state stuff, it actually just goes away. So this is going to be fun. fun. And it's actually going to explode our code a lot. Quite a lot. Because what's going to happen is each of those states that are treated as functions has to be written in two different places. So for batch processing, here it is. Initialization, I'm fine with. If it's a switch statement or function or a pointer array, if it's a function pointer based, so essentially, first of all, let's start by doing a test. We probably should. So in here, go to tools. No, come on. I already borked my shell. Not borked, but made it inconvenient. cd tools /test permutations test. So this removes everything else from the project. It embeds our code snippets. Now we're compiling the Tokenizer Generator itself. Then for this test, it uses this combination of build options to build the output of this program, and then test it against all three possible encodings. And like I said, there's a lot of combinations of things. These are all iterator based. These are all dispatching by switch. This is by function pointer array. Function pointer array comes in two flavors, right? One where you use bind and one where you use lambdas. So yeah, just everything, all the different combinations, all the code paths are exercised by this test. So let's run that not real quick, I suppose. Let's make sure things are in a happy state before we start adding new features. But goto is the one I'm most excited about because it's the thing you don't actually get to use very often in modern programming. I use it for a couple of things. This is one of them, DFA state dispatch. A prototype of this that I wrote years ago now only used the goto method, so it'll be interesting to compare the performance. I'm not even sure. So here's another question for myself. How much is this going to explode? Well, do I test performance of the tokenizer alone, or once I have the LALR parser generator done as well? Because ultimately, I don't think most of the time is spent in the tokenizer. I don't think that much time is even spent in the parser. It's almost all spent in semantic analysis, optimization. Even code generation is pretty fast. So we may be wasting a lot of our time optimizing all this stuff, but that's the way it's going to be for a while. Like I said, we're not really interested in efficiency, programmer efficiency, my programmer efficiency. But in the end, what we want to do is craft a very nice, very complex. Well, it doesn't have to be complex. I like simplicity where it belongs. But a thoroughly tested, I guess, set of tools. A lot of people are like, oh, well, it's not important, doesn't matter. But what if you could save a couple of milliseconds per JSON message being sent across the internet? What if it parsed just a little bit faster? Hey, JTL, yes, happy compiler day. But if every JSON packet that was sent across the internet was parsed just a little bit faster, you're saving power, you're saving time, and it adds up. Talking about economies of scale where small improvements might be a huge difference. So we'll see if we can get any good performance out of this thing in the end. Who knows, maybe some of my good ideas are actually really bad ideas. But I would like proof. You can't measure it, it's not improvable. And the world is too complex for me to have a strong intuition. I have intuitions, and I'm going to make performance predictions before we run the test, the final profiler. But okay, so everything is working. Every code path we have right now passes all of our tests. So let's go look at our test. It grew a lot last week. It was very, very encouraging. So we have a manual test. This is the one I develop against. Then we have an automated set of tests, which looks like this. It cranks out some different sample texts, and then automates it, and then automatically tests against it. And we can say it has to, here's the label to label it with, but maybe we expect errors or warnings, right? So all of that is in here now. I think here's all the combinations so that when we do run the test, we can see what we've said exactly. So yeah, I think for our testing purposes, manual test. We can test with Latin 1, UTF-8, or ASCII. We have not run an empty test. Okay, that's another idea to test against. I'm not going to do it today, but you can easily get in a state where your initial setup is done. You hit the end of the file because there's no text in it. It's an empty text. And then things break because it's not in the state you expect. We need an automated test for empty files. I thought I had a log file in here. Oh, tools. There we are. And this is all logged, so all those tests outputted 10,000 lines of details. So we got an unterminated token at the end of the text buffer that cannot be accepted. We expected this text, so it passes because we expected it. We did get unexpected characters, so characters that weren't defined inside of our tokenizer rules. We expected 2 of those, so that passes. So yeah. So we can always look and see where things failed to succeed. And every single one is clearly documented, so I can figure out which combination of things broke stuff. So we are starting goto processing finally. It's all going to start in our code snippets under VV project parser. No, it's not. Tokenizer. So this file is basically all the boilerplate that goes around everything and doesn't get into the details. Where there's a ... I insert code. This is like a template file. I insert code here, which says what to do with each individual state, right? So what we're interested in is here, process. I wish there was a better way to visualize these if-defs, but it'll be fine. So if we're dispatching by a switch or function array, function pointer array, or function pointer, actually, lambda bind function pointer, that's this one. Okay. So here's where it goes. If def dfa dispatch goto. This is going to get wild. So the initialization is fine. But basically what we want to do is say go to someplace, our start state label. This will be replaced in our template. What process is this? So we're starting a new chunk. End of chunk 2. Oh, no, not here. Not here. Dispatch switch, dispatch function array, dispatch function pointer, dispatch goto. It goes here. So this is the end of chunk 3. Go to start state label. And that's basically it. All the rest of this stuff doesn't happen here. So this is now chunk 3. So if we need to find, renumber all these other ones, and then we do this so that I can keep track of where I am. This file in particular is a bad one. 8, 9. This is where we stitch together all these code snippets. So tokenizer 1. Temp label. So there's an enumeration which uses this, but I think I can use this for my labels. If anybody wants to know more about labels and go-tos, let me know. I'm happy to dive into details. Maybe just start state label then. Chunk 2, chunk 3. Start state label. Yeah, we're just going to try that. So chunk 1, chunk 2, and now chunk 3, right? Wait, yeah. Go to dispatcher. This is going to do very little, but we just want to stub it in, right? This is going to create a duplicate of a lot of code, or near duplicate. Okay, set depth, I think it's just 4, so let's look at our tokenizer. Oh dear. We don't need this while loop in goto. So I think what we do, let's do that. We do that. We do that. This goto doesn't need it. Returning the favor and joining your stream now. Hey yo. Good to have you back, AK Elements. How are things going? It sounded like you were on a bug finding day. I've got a list of those building up for my other project too. I don't like days like that. It's sad, I guess. It's like all this stuff was working, and then all of a sudden it's not working anymore. It's like, wait a minute. Everything is so not fragile, but like interconnected. Code is just so interconnected. One small change and everything breaks. It seems like. One, two, three, four. Okay, so we're gonna go to a depth of 3. Oops. Here we go. And then we're just gonna blaze through here real quick. Not really. I wanted to move my render frame graph that was built at the start of the year. Okay, to the new node editor. Node graph system opened a whole can of worms. Yeah, had to move code around so you don't end up in some dependency cycles. Yep. That makes sense. Replacing an old system with a new system, that's not so bad. But yeah, it is a can of worms. A can of worms. Well, hopefully you get through all those worms pretty quickly. All I'm going to do here for now we're going to write a helper function eventually. So we're going to do let's just make a bunch of labels. If state equals, oh, let's see here. Here's your definition. DFA start state. Well, I think that's about it. We just want to print something out in that area and be done. We're going to let's want to change up the make file a little bit. We're going to go batch processing, dispatch, go to. There we go. Now we're going to clean Debug build. 77 files later. Oh, yeah, that's a big commit. The big project module restructure is done, and tomorrow I can start with the render graph move to the node editor. Nice. No, it's looking good. I like it. Looks like you've been making some very good progress. It's nice to get a big refactor done like that. You pause like at the edge of the cliff, you look down, you're like, oh my gosh, can't even see the bottom through the clouds, right? And then you jump and you just keep grinding through those compiler errors over and over again until you hit the bottom and it's done, and you can look back up and say, that was painful to go through, but I'm glad it's done. Okay, so now we have to, well, I guess we can do visual inspection for now. We're not doing anything with it. So let's see where goto happens. Oh, we haven't run it. Let's see. Let's go into test. And all we're going to do is suppress this thing. Test.vv tokenizer. So this one is the UTF-8. So we'll use a simple UTF-8 example. Log out our define statements. Print out our text. Tokenize it. Begin and errors, warnings, and tokens. And then print out the lines in the text, which we actually don't need to test now. It's been working pretty well. So I think we're good there. Yeah, and it's for the best. Yep. The core of the asset system is now independent from the application code, okay, which was the highest module. This enables me to move some code down to the modules it belongs to. Textures to the graphics module, for example. Okay, yeah. So lets you move things around in logical ways. That always feels good. Okay. So we have a test file. So let's do a test build. All right, well, this is what we're here to look for. So we have our goto. A bunch of labels. And then apparently we have to then hit the trailing bit, which is fine. That shouldn't be any different. Let's see what other errors we get. So what we're going to end up at, so let me go find the example project. Battery core. What did I even call that? Billy Tokenizer. What did I call that? Oh, it's in VB parse Billy Tokenizer. So we'll end up with something that looks like this. We're going to go to our start state, and then that's a label. We'll do the same logic we were before, except there's no return. It's literally just go to the next state. So let's go to state 9, we just find the label 9, and this will reduce function call overheads, which I don't know that it will be a performance improvement. You'll have to wait and see for that. So yeah. Okay. So this is kind of what we're aiming for. Every state looks like this. And we're just going to use gotos. Which we aren't even that far off of. Sort of. I'm just trying to decide where to start. There's a number of tasks that have to happen. So let's go to if you project, write DFA, go to state. It needs the writer and it needs the state we need to write out. We're just going to separate this out. Write DFA, go to state, giving the file writer and the state. Okay. If it's the start state, okay, that's part 1. I suppose we could write an empty statement for now. Writer point 2. To do implement. It's still going to have lots of complaints, I'm sure. I think there are other elements of our tokenizer that it's just assumed functions exist that no longer are necessarily defined. So maybe that's what we hunt down next. Interesting to note for myself. Okay, so that's one more little piece we've got to clean up then. In the old tokenizer, on dispatch, none of these actually need a multi-line statement. I think. This one. Yes, we're writing code, reading the config file to generate code that will read code. It'll be great. Okay, labels that are defined and unused, that's fine. Accept is going to get a little bit more complicated. Oh, only sort of though. So in this case, accept is a function that can do some work, but it doesn't have this label scoped. Therefore, we have to do the go to ourself after we do the accept, which is fine. So let's go do that. Code snippets, VV test parser, what is proj parser, and that's in the void accept. Oh no, it's in tokenizer. So that actually just goes away. We have to think about all the different combinations and permutations of code we're dealing with. Since we're building our code to okay. Oh wow, that actually isn't that bad. Let's just go to 1. Okay. So state 0 is a start state. Do nothing for now. That's all going to change shortly. If we do accept different accept methods, go to. So this go to also goes away. Oh no, this doesn't have to. Because these are macros. So we actually keep this one right here. If we want. Let's not. There's a whole other round of accepts. Okay, here's what we're going to do then. We're going to leave it in such a way that I can bring it back if I want to. There. Okay, so what we want to do is we want to go find the code for DFA state methods. This is emit DFA state. This is very close to what we want. Change the name of that so it's clear from my code what we're doing. Emit DFA state method. And we want something exactly like this, which we've already stubbed out. So let's see, project emit DFA state go to. I think that's what we want to call it. Emit DFA state method. So I'm fine with that. Emit the transitions should be fine. If it can accept, then we accept. That's a problem there. So actually, a lot of this is very, very similar. We can actually leverage quite a bit. Right line, basically this. Here. Except emit transitions needs to change. Blah, blah, blah. So much of this is true. Up to here, up to here. This is where things sort of change. Except, it's not true, is it? This is how we choose our next state. So all we have to do, oh, Let me think. So there's basically two methods here. One is the function-based one where we have these different pieces. And that makes sense in the function-based one to build that way. But in the goto-based method, so we just pass a flag. It's quote-unquote bad design. Emit transitions. Bool is goto equals false. That's all we need. The only difference is here. If it is goto, we write out one thing, otherwise we do all of that. In this case, what we do is we say go to this. Transition state next state ID. And that's it. So when we emit transitions for goto, we make it true. Let's see how close that gets us. Code generation, always fun. Like I said, this is going to double the size of our project almost in some ways. We may not have renamed it in all the right places. Init DFA state method. I did not put this in the right place at all. This is in emit transitions. That's where that goes. I don't mind if the last piece of this doesn't build. Oh my gosh, it worked. So reload, find goto, blah, blah, blah. Here's another place where I use goto, basically for error handling. All right, we go to our root state. There is state 0. Rule ID munch, go to the next place. These are all going to 1, which I don't think is correct. There's state 1, which is a very short state. DFA state 2 checks for new line. I'm a little bit puzzled by this. I don't think everything here. Oh, a lot of things go to 1, but not everything goes to 1. Things go to 1 if it's like a 1-character match. So we get a closing bracket, we're done. So it just goes to the accepting state, which is 1. Perfect. And we still handle Russian characters and Greek characters. There's our non-breaking space when we're checking for white spaces. Okay, actually, ooh. Nope, that's fine. The rule ID works fine. This kind of works. So, one more thing we need to do. When we're emitting accept, it is goto. We want to go here. Which is root state thing. This is not replaceable. And this is tokenizer definition, DFA, start state, state ID. I think that's it. Now, if we go with the part of me still wants the did I not block out two of them? I did. Right line, if defined, we care about the helper functions. There. So after we accept, if we're building with functions, then we have to do the goto ourselves. Otherwise, the macro should just handle it. Which right now looks like an increase of 3 lines of code per accept state. But in the end, when we strip everything out, it won't be that bad. So where is accept? Just this one. Oh, this one? Here. If it can accept, if the state can accept, then we accept. And if we are in function mode, we do the jump ourselves. Nope, nope, not in method. Method, nope, nope, nope. I need to go to, and this one. We'll see how that goes. Oh, shockingly, not too bad. On our makefile, we were suppressing this build, where we're actually building the thing. I think we can just do it. We're going to test this for a test drive. And if that works, like if that compiles, we may just run a quick test. source builds debug pv test parser exe. Okay, we're dead. It's done. Stop. Well, let's try to figure out where we went wrong. Pound defines, there's our text, processing begins, and it's adding a bunch of error messages, which is not helpful. And it's stuck in some sort of infinite loop, so. Oh, wrong keyboard shortcut. Did not want to close everything. Oh, size for stream. We want the performance switches. You really do want the project back. We really want Tokenizer back. Now we just have to figure out what we're doing wrong. Which I'll just think about for a second. I feel like we're actually close, which blows my mind after only 1 hour of work. I think that we're maybe actually that close. I'm going to take a quick restroom break while I think about it, how to best debug this. But be back we will. So just a moment, we'll debug this. Okay, so it's stuck in an infinite loop. We can turn on the trace debug thing, which might fill up too much. I would like to go to where the context blows up. Basically, we only have a fixed number of slots for context messages. This is where we store all our error messages and warnings. So it's doing something wrong, getting an error, and then looping without progressing. inside that. So I just need to know what one of those messages is. Now, I am eternally optimistic and forever thwarted on this project. By the fact that, why is that open? It's not helpful. By the fact that I can't actually set a breakpoint correctly. So if we run this with this breakpoint at VV, let's here, let's do this. Dir equals source. And then in VB test parser, .cpp online 897, set a breakpoint, and then we run it. Boom. Oh my gosh, it hit a breakpoint at line 919. Why? What is 919? That has nothing to do with any of that. See, freaking debugger. What? This has nothing to do with anything around there. This doesn't help me at all. Okay. Let's do this. Format args. -1. So the last entry dot message. And then exit -1. I don't like doing it this way, but you know, do what you gotta do. Too many messages. Printf exit 1. Give me the last message. Let's see what that gets to. Clean debug. It's running the debugger. For whatever reason, this project sucks. I don't know if it's GCC or GDB that sucks the worst, but I think it has to do with how many pound defines I've got, like blocking off areas of code. And there's an intermediate stage where it does text replacements, so then those parts of those things would go away. Nope. That did not work. It did not exit. Oh, good heavens. Loaded snippets. Context. What? So I've got this new code snippet thing. Context here. It's not here. Oh. Clean test. There we go. Okay. That might make a difference. Clean debug only builds the tokenizer generator. Clean test uses the output, generates output from it, and compiles that. So source builds debug db test parser. Boom. Unterminated token at the end of your text buffer cannot be accepted. Oh. So goto is actually shockingly close to just working, isn't it? Fascinating. Here we go. Here's our goto. And everything keeps going back to the state label in an accept. Oh dear. It's going to keep going back to state 0 no matter what. Oh, okay. So that means we can't do this here. Oh, no. It's the goto ones we care about. This one. And this one. And project. Where we're saying if is goto. This doesn't work. This is goto actually simplifies. Because now it doesn't matter if it's a if is goto. So the only except that doesn't bounce back to the start is the one on the exit. Okay, here's where we do the old trace thing. Make file, trace log the tokenizer. Now we'll see every step of the way. At least we'll have some idea if we're going in the right direction. Whoa. Line 7 characters, so munch to nothing, yeah. $474, $478. Hmm. I feel like we're so close. VV test parser. Okay. Okay, so what about this? This here needs a label called DFA complete. And in VV project, emit DFA state goto if it's a start state. Then we ask, if m_current dot Oh, wait, we have is done, right? Is done. Then we go to DFA complete. Gives us a way to exit when we hit the end of the string. I think that's the only piece missing here. Because everything else was inside that while loop check. So if you look at the tokenizer, these while loops, while not is done. Whereas this one, we're going to enter that start state. So VB test parser, DFA complete. Start state. If we are done, go to DFA complete, which is here, which does this part. This except, let's look at the except methods. Why is this here? Oh wait, this is fine. This is not the right one. Yeah, here's the go-to one. And here's the go-to one. So that's all we get. I think. Okay. Source. Source builds debug. VB test parser. It worked. Okay, so we got our Russian Yutsu. Hello, Omega, comma, X. The line numbers 1, 2, 3, 3. Line 4 has Slon. So Russian elephant. World. Exclamation mark. Things and stuff. Period. 1, 2, 3, 4, 5. Khlieb, so Russian bread on 6. Confetti, Russian candy on line 7. I think that's source test.cpp. I do want this back. I don't need to necessarily see all the lines. I think we may be good. That I expected to take all day, but I think we're there. Run it. We get our 8 lines. Line 1, 2, 3, 4, 5, 6, 7, and then the 8th blank line. All the tokens are there. Everything's there. Perfect. I think all it's really left. Let's hear. Journal. Implement or enough to get manual testing to work, pass. Add to automated testing. See which other build combinations fail. This is actually the same test. We add it to the testing and then we run it. But I strongly suspect that right now, most of the testing should just work. So let's go into tools, test the permutation stuff, 5. So our permutations right now are these 1, 2, 3, 4, 5 dispatch states. And we're just going to short this. So our dispatch options are 1. So we're going to go through this a lot faster. And we are not going to do lazy testing, only batch. Everything else, I think, is testable. So cd tools, time /test permutations.py. And we're going to just see how that looks. We're going to run goto against every other build combination and see how it goes. So it's rebuilding our Tokenizer Generator, and then for each combination, is it stuck forever now? Are we broken already? It looks like we're broken already. For each test setup, it executes, it builds a project file, executes VV, the Tokenizer Generator on that project file, builds the result, and tries to test it, but we seem to be stuck, so that is unfortunate. But the manual build works. So I like these in the other order. It doesn't matter. Text, iterator, dispatch, goto. Okay. Compile and run test. Let's start up the files. Compile, execute test. So we're going to pause that. Just so we can get everything to compile. Okay, so we're going to rebuild the tokenizer from scratch. Okay, and we have a lot less combinations we're going to even test against. As long as they all compile at this point, I'll be happy. Go to batch. So it's basically a test of iterator, check character advanced functions, and macros. Oh, which is fine, yeah. So that would really be 4 tests to test what we currently support in GoTo. That would double if we had lazy processing, but we don't. So our make file. We're going to do it ourselves. We're going to set it up so that we have, sure, fopen. Iterator, I don't think is the problem. Functions, batch, GoTo. Iterator, GoTo, batch functions f stream. Okay, what we're going to do is we're going to break on the first one. So it's going to build test one, and then we should have that executable that we can run. See what's going on. And it will hang, so we'll lose all this shell. So this is the output of this command build. No. It fails to discard the comments correctly. Okay. Go to test. Discarded. So let's do that and see what else we get. Well, that's not what I wanted to do, but okay. Shoot. What we want to do is this one again. Rerun the build. I'm actually shocked we're this close. It probably means we're going to run into a whole bunch of little subtle issues. Okay, ends with incomplete, which is this one. Okay, that actually kind of makes sense. So it's getting the unexpected character. But it can't accept. I don't remember what that test even looks like. We're shockingly close. We have 3 tests failing. Yeah, we only have 3 tests fail. of which this one is probably the closest to working. The other two dump the stack, right? Unexpected character. What happens in a DFA state when we get an unexpected character given the current? So we get an unexpected character. Munch. Start new token. So it does not accept the previous token. It advances the character. Unterminated token. If we do accept actions. Oh, if we start new token in this situation where there's the else, we have to go back to our start state. This is an error. Start back up at the top. Okay. So this just did a fall through into here. Easy enough. Add message, which is basically this one. Start new token. This is go to. Then we do that. I think that may just fix it. Oh, okay. Then we run our test. I don't see that code in here. If this is a go-to, Hmm. Right out the gate, we're passing. Okay, so that's working. Redo the thing. Oh, so that did pass now. Okay. Okay, ends with discarded token. So this means that the text we're testing against ends with a comment. And this part is failing with a stack dump. So let's just do a quick build and clean. Like I said, I'm a little shocked at how well this is going. Oh, let's do this. Let's do this. Let's not do that. Let's not do this here. Let's run this. So the first one at least should pass. There are 4 tests. It ends in a comment. So let's go look at how that state goes. We should munch until new line character. Or end of text. Is this hanging? Oh, got it. All right. Put the break back in. Tools, / test permutations. It's just a build, it's not a run. When we run it, it passes. So it should be passing 4 tests. What order are we walking? The encodings. We start with ASCII. So is ASCII hanging for some reason? That would be a little bit odd. But we can reverse the order. Okay. Now let's have something we can look at. Fail, fail, fail. Oh, okay. I know what's wrong here, I think. Because I reordered those. Reach encoding and encoding. If encoding equals ASCII. Okay. So we expect UTF-8 to work. What? If I put string quotes around strings, that would be good. UTF-8 passes. Then it generates a new project file, compiles, and runs against a new set of strings. Latin 1 doesn't work. That is interesting. Why would Latin 1 behave any different from UTF-8? Heading out, falling asleep here. Yeah, don't blame you. Long work day and then stream. Yep. Good luck with compiler. Thanks. You have a wonderful evening. I'll catch you around. Poke in again at your stream. It's always entertaining. Have a good weekend. Okay, we're going to make more project files. I think that's the short answer. Test ASCII.vv project. It's basically this. Test ASCII. ASCII.vtoke, which is basically this. Okay. Test Latin 1 vtoke is this. Plus I sure hope this works the way I intend. Of course, I'm not sure it actually does. Pixel mode. The last few characters. Have all been replaced with UTF-8, I think. Is it's weird comma, percent, oh no, not weird comma, what am I saying? Upside down exclamation mark, 1/4 through upside down question mark. Bracket 5D is matched by this bracket here, 5B. I think. ODOA, this is a new line carriage return. Well, carriage return line feed, CRLF. Which means this is not actual correct Latin 1 encoding. That's frustrating. Still. Latin 1.v project. Latin 1. Yes. Okay. So I need to force this file out here. It's Latin 1. I need to write this out specifically. Coding Latin 1. vtoke. I want it duplicated somewhere off to the side. Or we can just cheat. Let's come to encodings. Let's put Latin 1 first. OS, let's see, copy file. Python copy file. shutil copy file source to destination. util.copy file from temp.vtoke test.latin or test latin 1 dot vtoke. What is tester? Is the root directory. Okay, that's like the project directory. Okay, so the first thing we're gonna do is we're gonna move that's Latin 1 vtoke. Then we're going to cd tools /test permutations. And that's going to hang after UTF-8 completes, right? I think that's what we decided. shutil is not defined. I guess that makes sense. As long as it outputs that file, I don't mind if it hangs. UTF-8 passes, and then nothing happens, and it's going to hang. Because something's going on with Latin 1. Okay, so there's my end of line bracket 5D, then it's 2, 1. Comma 5D bracket BF, and so these are think oh, that's another thing I should do. Let's see here. That's our Latin 1 encoded file. A is 10. 8 plus 2, yeah. Okay, so I think test utf8.vd project utf8 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 code. I know I'm going to steal this line, which hilariously is easier than stealing the Latin one encoded. Okay, so in theory we now have essentially the same test files set aside where we can play with them manually. Okay. Manual test. Right now, manual test is not very good at testing some basics or ASCII. I guess we can just do it this way. We'll just switch over to ASCII. Clean and debug. Test command. We want to generate a new tokenizer. And basically this. Except it is test ASCII VVEXE. Hmm. Right. That's not entirely true. What other backslashes can there be? This is a similar pattern to the converter. No need to escape character. Backslash, backslash. Temp. This is all inside a character, escape character check, right? If we are inside of an escape, and it's not one of the known character classes, we are allowed to escape these characters to make them literal instead of functional. One of which is a backslash. Should be backslash enter escape. Backslash is the character literal. Then dot for anything. Oh, no need to escape character quote. That's because we're not in C anymore. Correct. Okay, I see what it's saying. There we go. Woof. I forgot when I was copying that out that we had all that escaping in there. So let's see here. Test Latin 1, toke. I just want to make sure these are still 1 byte values. Looks like. Okay, so that's part 1. Okay. We put this on the make file. Maybe we put this on the make file. Test ASCII. Essentially do this. Build proj equals test ASCII.db project. We'll get around to that in a second. Latin 1. UTF-8. The plain old basic test that I've been running. The more expensive, and I believe UTF-8 is the usual. Okay, now in that case, $proj, which is being passed in, dash o source, this pound defines dash d Manual build encoding. Oh no, here we go. Manual UTF-8. Manual ASCII. Manual Latin 1. Okay, so we generate with given project with the given encoding. Let's simplify a little bit. Okay, then in CCP. Okay, pound if def manual ASCII ASCII Latin 1. Finally, Latin 1 to UTF-8. Okay. When we log it defines this way, all of my encodings are synchronized when I'm testing manually, both from the build perspective and from the configuration file perspective and from the test string perspective. Just gonna grab these. Go. One more thing we want to do. If well, pound if not defined manual ASCII Latin 1 not UTF-8. We're just going to take the UTF-8, right? Oh, we can do empty. We'll figure this out. Compile, clean, test UTF-8, because that was working before, so it should work again. Maybe. Right, well, that builds 230. So build completes, source builds, debug, DV test parser. That works. Okay. quick restroom break, then we'll get back to testing ASCII. Be back in a minute. Okay. So we can now compile test versus ASCII manually. I'll do the whole shoot and match for us. Now when we run this, it blows up stack dump. First character is valid, or this is an assertion. So this is happening when we're creating a string, I believe. Yeah, string reference from two character references, basically a start and end character reference. And for some reason, ASCII doesn't work like that. Log defines ASCII Latin 1 UTF-8. How are none of those built? test ASCII. Why did that not print out to the console? Because what we have here we put this encoding at the wrong place. Not this one, we want it here. That will work a little better. Which means this was kind of working, but I still don't like it. Right, so we're doing kind of this. We're taking this as the default. We're doing that. Okay. Test ASCII. Then we can run the manual build. I forgot about that. We're going to fix that already and got distracted. La la la. It's always the encodings that seem to bite me. Boom. Okay, so that's working now. Which is interesting. Hello, comma, world, exclamation mark. Okay. Latin, oh. Latin 1. We're going to give that a try. And hope it works. So this thing and this thing. Okay. I think I can fix this. \244 versus test permutations dot pi. Let's add the upside down exclamation mark. 241. There we go. And the omega is an unexpected character. It's actually 2 unexpected bytes. So if this works, this runs clean. Hello world. 241 world, exclamation mark. Yep, looks good. Now my terminal isn't interpreting that character correctly because my terminal is in UTF-8 encoding. So when it gets an Latin 1 encoded character, it can't display it. Hence we get the 241 back out as a single character. But all of that is as expected. So one could argue that's good too. Therefore. Therefore, where did we leave off? We are breaking after the first round of tests. We are trying to execute the tests. Go to tools, / test permutations. Okay, UTF-8 passes. I don't think ASCII 1 will. So we check our log mid-run. No good. So if we run this manually, what do we get for output? End with discarded token whitespace. What is different about ASCII? Which causes it to hang there. Do accept actions. That's okay. Start new token, start new token, start new token. Everywhere inside here that does a start new token, we're discarding a lot of tokens here. In theory, every space and tab goes to state 3. State 3 says, is the next thing one of these? If it is, we go to 1 and munch. Okay, so this is a problem. Oh, no, it's not. We munch the character, go to 3. So we keep coming back here until we don't get something that's one of these two. Whereupon we accept and go to 0. if we're done, we go to complete. Go to 3. We turn on trace logging. We're just going to get DFA state 3 and 0 over and over again in that infinite loop, aren't we? Is Latin 1 character ref is done. Oh dear. When we advance, our update may need to be fixed. I think that's maybe what's going on here. If it's false, this, but then we have to change the value. Something invalid. So when we test for equality, these equivalency tests, this is our problem right here. If they are equal. Okay, so one question is, is valid, and this is what needs to happen here. And here, and here. These two, I don't know what to do with. So let's go to assets, code snippets, character reference for ASCII. Operator equals is valid and is valid and is valid and character reference Latin needs a similar treatment. Okay, that may fix that issue. What happens in, well, anyways. What is valid? Oh, good heavens. Underscore is valid. And at James Arts. Hey, how you been? I've been good. How are you doing? So far, so good. What's new? Okay, so we were running into issues where it was an unterminated thing. Therefore, if we go to here, we add a trailing space. That should be the same level of testing. Nice. What are you up to? Well, we're building a tokenizer generator with no libraries, no dependencies, using NFAs and DFAs built from regular expressions. We're testing an awful lot of permutations. So we're going to do /code. Just give me a second. Let me finish this thought here. Permutations.py. Oh, test permutations. Okay. What are you up to? So UTF-8 still passes. Now Latin 1 passes. And ASCII passes. Therefore, we can run all the tests against these. And that, I believe, are 4 tests. There we go. Oh, I revamped my stuff. Took some time on the Discord. Make a new version of stuff for your channel. I did see those. I was going to respond, but time to stream. Yeah, I'm not really looking for an art revamp right now. The art that I already have is good enough, and I actually think the stuff I had before was more readable. I think the new stuff you've made, like the colors, some of the color stuff looks better. And having the gold options is nice, but I think it's harder to read. Okay, so we have some fail on the helper macros. Cool. We are much closer. Something in the macros isn't working right. After the stream, got some time to talk on Discord, we can discuss there. Sure. Sure, we can discuss it after the stream. So the question is, what is going on with the failed tests? Something different about the macros. Macro processing is broken for goto, and that may actually not be that surprising. Batch rule, start. Accept. Let's see. Start new token. Start new token is just bookkeeping. I don't see any issues with that. We're not doing lazy processing right now. And of course, the macro version is the more difficult one to debug because we don't have log tracing through that. That's unfortunate. Okay, so all the macros are defined above. That's well, let's see here. Start accept is done. New line, munch. We should do that. Macros. Is done, shouldn't matter. New line, munch. Huh. Okay, I'm not sure how I feel about all that. One terminated token at the end of your net text buffer cannot be accepted. There's a discarded token. Huh. I should only see this token once. Test UTF-8. 4 errors. Why would it go there 4 times? This error should only happen once per run. Oh. No. It all has to do with this. Terminated token at the end of your text buffer cannot be accepted. Except, is there anything goto related in here? I don't see any. Only the do accept options. Huh. Hmm. How to test. Cool. Or log. In the tokenizer. Changing the way the logging is done a little bit so that the macros can get similar treatment. Now we can at least see what it's doing and where it's going. Ooh, multi-line, look at that. Whoa, nope, not that one. Okay, now. Okay, so far not worried about any of these, but here we go. Every except pushes and pots. I didn't want to do it that way, but it's okay. Now, start new token. There's another accept list. Oh, okay. So that one. Munch. Let's do the new lines. There's only one of those. There's not that much difference between the different processes. Munch new line. Start new token. Accept is done is not interesting as a log statement. Therefore, it's just a munch left. One, two. There's only two versions of those, so in this case, we get our current string, then we advance, which is this. Then we get that string, then we output that. Hmm. character line. Happens either way. And in a way that doesn't interact with the rest of that code body, so. Does that fix our issue? Just by virtue of the fact that there's gotta be something wrong with the munch, right? If this doesn't fix it, we will add to our define list. Yeah. Macros are still busted. There's something we're doing in functions that we aren't doing in macros. So we gotta figure that out. Yep, same kind of errors. Okay. That there and that there, just because we can. This has to do when we're in macros. Just take a very quick test drive. Oops. Oh. Missed the garbage can. I'll pick that up later. Darn. If log. Causing me issues. Start new token. All right, fine. Ram. So things aren't popping correctly. Process, start new token. DFA state, munch. HE, so we're not PFA state PFA state if underscore log, do that. Oh, there. If we can accept, we do that. Hit transitions. Go to see if that gets us a better output. We can read. Which probably means oh, let's see what happens. Okay, 0, MUNCHGLLO7. We accept. Keep the token by that rule. Start a new token. Okay, so our accept macro isn't popping. Switch pointer lambda go to this one. All I want to know is what's going on. With my macros. Okay, state tokenizer accept keep start new token. We're still missing a pop after an accept PFA state. Is go to that one right there. Yeah, if I get my output structured correctly, it'll be a little bit easier to trace through and figure out what's going on where and when. Whew. There we go. Okay. HELLO 7, we accept, we start a new token, enter state 0, blah, 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 blah. Context. Add message. If defined, trace what's it called? Trace log tokenizer. Printf error. So that should stand out. Ugh. That should stand out when we trace log now, where the error occurred. If it all happens at the end of that process loop, that's not very helpful. What? These three errors, unterminated token at the end of your text buffer, cannot be accepted. That happens in Tokenizer. Here. So when is this happening then? Error. Not sure what's going on here. Okay, there's one. There's two. There's three. DFA state 2. I should never go from DFA state 1 to DFA state 2 after accepting. Why would DFA state 1 be going straight into DFA state 2? 0, 0, 1. Go to 1. Here it is. If that, then except, then pop then go to 0. Oh. Only partly do I understand this issue. If helper functions. It only shows up here. How can state 1 go to state 0? Have no transitions, that's the one that goes. So state 1. Otherwise, it all relies on the accept. In Tokenizer, accept if log push pop push pop goto does need this. So go to backtick start state ID. I thought we had this in more areas. Okay. We'll clean this up. 1, 2, 3. And where's that go to start state? This. It was falling through because we did not put this here. I think that's the answer. Okay. Whew. State ID used but not defined. Okay. Go to state. Define start state label. I think is the right one. Oh, nope, 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 nope. Label. There we go. Which goes right here. I think we're close. I think that's mostly it. And if that's the case, we may be able to unleash the compile, the build tester on everything except lazy. Perfect. I mean, not perfect. Printout's not right. But we can leave that as a task for the future. So let's remove this piece for now. Go to just do a clean build ASCII. Let's see how that looks real quick. And if that works, we may unleash more of the tests. Boom, perfect. Therefore, let's in test permutations. We've got basically 4 combinations, and it will run them. Okay, so cd tools /test permutations. I like to run time with it, just have an idea how long things take. It was 14 seconds for 1 Tokenizer Generator compile and 1 test compile. So in theory, this is with the helper functions. Helper macros are now passing. Oh, look at that. It's beautiful. So beautiful. Yeah, perfect. 12 out of 12. So, test permutations. We are going to run 1 full suite of tests, except we will short out if it contains goto and lazy. Build permutations. Result append. File IO. If dispatch equals that and proc equals something else, continue. doing goto and something else. Proc. We do not test proc dispatch and lazy goto and lazy. We'll skip those ones. Otherwise, everything should be good. So I don't know how many tests that is exactly. But if we are ready, this could run for a few minutes. I mean, really, it's only added 4 more tests on top of what was already taking us a couple of minutes, so shouldn't be too big of a deal. But we should have 24 full tests now with, well, maybe more than that. I will see. Oh, shoot. Iterator, dispatch, switch, process, batch, helper functions. Thing to run was this, so the build failed in sad ways. CD source, run this, DFA complete, defined but not used. Oh, interesting. That's not that hard. DFA complete. There's only want to do this, actually, that's it. We just do that, right? Builds. Relaunch the test. Oops. Yeah, failing a build isn't great, but it's easy to track down and retest after a fail. All right. Test 3 was where it died last time. 5, 6. Yeah, look at all these combinations we're getting. "24 tests times 3 encodings." What was that, 72? 72 tests. And each test tests. Oh, wait. Did I forget to uncomment our tests? No. This may still blow up. All right. We did some testing, but not. Oh, shoot. So this is the function pointer chunk. If the batch one runs once, oh dear. We really shouldn't be editing this code file in the middle of testing. But I am curious. Because each one of these is a new build, so after we edit that file, it will affect the next build. So function pointer, lambdas and binds. 3, one more lambda one, I think. There we go. Now it blows up. Okay. Rerun. We get the old command that failed, which is a build, which is good. Boom. Next state ID equals. So if it's a go to state ID is not needed. 1253 test is VV. I know. VV test parser. 1253. 1253. 1253. It's the one inside begin if we're not in goto. Listen for that text. Tokenizer. Okay, then down here, next state ID only matters if we are not if ndef dfa dispatch goto. Next state ID okay, I think that fixes that. So we rerun our test. Let's cheat a little bit. Let's cheat just a little bit. Let's also break out of here. If dispatch not equal to this, we'll break out, or continue rather. We'll just skip everything that's not a go-to build. Let's see. Dispatch not equal to go-to, continue. I want dispatch on the outside personally. I do want my dispatch done backwards for now. I want go-to at the top. So we get to our initial testing faster. We'll try that. Just trying to get the information we need as soon as we can. Something failed. Oh, damn it. $12.53. Where's my if not thing? Oh, did I put that in the wrong place? If ndef go to, yeah, so where's this? Oh. There is one other place. Dot process. If it's this, if it's this, if it's this. Actually, no. Begin. This is here. It's like it didn't embed the new text, maybe. Although it should every single run. That's a part of the build process here. Embed the code snippets to compile the Tokenizer Generator. Iterator, go to, I want to swap that logging while that's running. Test file is fine. I want the dispatch before the iterator. It's logged. And it's ticking. Why is it sticking? So we run that. Builds debug VV test parser. UTF-8 file stream go to iterator lazy. Why? Oh, I said lazy's not going to work at all. So that's why. Why is this lazy? That shouldn't be possible. If go to and lazy, boom, skip out. These are the ones I'm most in. Break or next? Is it next? Python is it next, right? Python next. Continue is next, I think. Break for a while. Blah blah blah. Break. Where's next or continue? Is it called next? No, it's called continue. Oh, wait. Nope. It is continue. If go to and lazy. Yeah. Test permutations. It should be, in theory, impossible to get a build that is go to and lazy. All right, let's do this. This is getting old. Dispatch in defines for DFA dispatch. Goto is the first thing up. For procedure in def process, lazy is the first thing up. So let's comment out lazy so it just isn't even a thing. We might as well do that. All I want is to test combinations here. 2, 3. Okay, something failed, but mostly succeeded. And then stuck. Stack dump. Well, that's not very helpful output, that's for sure. We at least know which combination fails. Dispatch process generator. So that one fails, and then this one hangs. Which is not encouraging. Go to and batch. Discarded token comment. This one compiles for slightly different set, helper functions, was fine, and then this thing runs, and it's fine, and then it runs this bad boy and hangs forever with no output. So this is not going to be helpful. um, Unfortunate. List processes. So let me think. The moral of the story is go to batch functions iterator Latin 1. Okay. So we come over here to iterator helper functions. Process batch dispatch go to. This doesn't matter. Compile test Latin 1. We're going to try this. I'm really glad we made this script, but so this, it's going to hang again. Oh, it doesn't hang again. What? Oh, because of manual Latin 1. Okay. But it failed which test? The .log says of course it doesn't tell me. It's the one that ends in comment, right? Test.cpp. This is Latin 1. So if I do this test, this should roughly recreate that test. I think. And then it hangs. Okay, so we can recreate it, and if I remember right, ending in whitespace didn't matter, just the comment one, which is a little bit bizarre, but think we're close. We're so close. It's just tracking down those last few little details of difference. Yeah, so there's a white space, it works. If there's not a white space, it doesn't work. Comment. We're going to go to make file. We're going to turn on this thing, rebuild it again, and we're going to at least see where it goes. Okay, we make it through 241. Comment, and then it just failed to proceed from DFA state 8. Munch does not go anywhere. Why does that not go back to state 0? Or, well, no, state 8. Okay, okay. Eats up the last space, and then it gets hung. So state 8. Oh, 08. This one. If the character equals that, which is false, then it goes to x8. Oh, okay, okay, I got it. Through yeah. Oh, this is the Russian? What is it doing in state 8? We should be in the comment section at this point. All right, I'm gonna take a quick restroom break. We'll have to come back and revisit that in just a minute. Okay, this is all a little bit odd. Take a look at something real quick. Okay, JTL, I got your file. I will take it for a test drive this weekend. So yeah, thanks. I'll definitely take that for a test drive. How are we in state 8? This log does not need to be here. So if I go to project, if log, I think it's this one. That goes away. That's not the problem. That's not the problem. It never goes here. It's like no man's land. Every branch has a go-to. The question is, how do we get into state 8? Build debug, maybe test parser. Eight. Munch. Took a forward slash. Go to 4. Alright, so let's go take a look here. In our test parser. 004. We expect the other forward slash, which should. Why is forward slash going to 8? 8 expects anything which is not new line or R munch go to 8. Oh dear. Okay, this is actually interesting. Okay, I think I know what's going on. When we do a not equals, we have to ask if we're done. Parens exclamation mark. Let's see here. Emit transitions is the important piece here. If not. If it's an exclusion, we have to ask m underscore is done. Or let's see here. Not is done. And so we have to make sure the character is valid and we are not the rest of the stuff. Is that it? If we're not done and none of these things. We can test this real quick. See how that turns out. Oh, yeah. So many little bits and pieces. There we go. I think that's it. I think that fixes it. Functions, batch processing, go to, yeah, none of this makes any real difference. Okay. So then, because that not is an inverted logic. So if an invalid character compared to a thing are not equal, and then you not that, it means true. So we have to make sure the character is true first before we compare it to the other values. Wow, okay, that was not what I expected. Okay, so CD, oh wait. CD tools. Test permutations. See how that goes. Okay, we're still getting fails. UTF-8 only, which is interesting. Error. Huh. UTF-8 is failing in UTF-8, and only when something fail. Go to batch macros, is that the pattern? Go to batch functions is fine. No, it's not. Go to batch macros. Error defines. I'm a little confused by that log there. Fail. Then these ones work. So this is the, oh, character advance instead of iterator. Oh, interesting. So UTF-8 fails on character advance. Branch. Right, so let's go take a look at the log. It's a big file. Search for fail. Okay, so it's hanging. That's why this is such a big file. Right here. Testing ends with an incomplete token in UTF-8. But only in UTF-8. Did a thing in here where we printed out the message. Right like that. Let's see how that goes. Oh, this may not matter. Let's do a quick build up. Yeah, UTF 8 character advancement is failing. So we could catch that easy enough. And an incomplete token at the end of the input. Oops, okay. Still the same thing, but too many messages. Unexpected character is, yeah, is a problem. Make file. This is with the this helper, was it? I guess it didn't matter. Still batch, still go to compile UTF-8. I think charref, whatever. This may just need to be updated character ref for here. Operator. You just need to do this. Not equals equals. This we care about. This we care about. This we care about. Make sure it builds. Shouldn't cause us any issues. Let's take this UTF-8 string. And we should be able to run the test without having to go through the test permutation script. Source builds debug. There it is. Oh, what? What? Oh, it's a supporting character, but not in my grammar. Could put it in our grammar. Just take it out for now. No, let's put it in. Can't make up my mind here. Okay. So test vtoke. Let's get the Greek letters. Then we're going to go to test UTF-8 vtoke. We'll put that in there. Then we're going to go to test permutations.py. We're going to find UTF-8. Do that. Because why not? Oh, yeah. Boom, there it goes. Unexpected character dot. It's
Winko's calling you.
okay. Just a moment. Gotta take a call.
It's Winko.
Okay, we're back. Nothing major. Just gonna put dot in here. And then test. Just gonna put a dot in all of these. Test Latin1 vtoke. Test Latin1 and Latin and ASCII. Put a dot in that one as well. I would like my basic testing strings to all more or less pass the same stuff for now. So if that builds and runs, it may be good. Unexpected character, line 7. So 1, 2, 3, 4, 5, 6, 7. If a state 6, unexpected character, nothing. Line 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh. Okay, so let's go take a look at that. Test parser CPP. State 6. 6. Unexpected character. So if we are not done, and the current character is not that, okay. This is not an unexpected character situation. This is a we're at the end. But we're not inside a while loop. We are managing our state ourselves. Therefore, oh, I think I'm out of water. We are out of water. Unexpected character. If we're at the end, unexpected character. This is the only place this is added. So we have this goto here. Therefore, else accept. If it cannot accept, if we are in a goto process, we do one thing, otherwise we do this thing. Right? If it's goto, then we have to ask if we're at the end. Yeah, what else here? Writer push underscore is if is done. The structure is like this. If it's done, we do one thing. Pop writer push. Okay. This is inside an else clause. Yeah, this gets complicated. Check for end of input and go to start. Because all of the that will try to accept or go to complete. I forget what it's called already. Tokenizer DFA complete. If it's done, I mean, why waste time, right? We know what to do. If we're done, go to DFA complete. Which means that goes away. So if we're not done, then we say unexpected character, etc., etc. Go to, now, if we go to a state, we should be doing this. In go to mode, right? I think so. Does that fix all of my issues? I think so. Hey, Javest, how's it going? We're doing good here. How are you doing? You're up awful late, aren't you? You're usually off to bed by now, aren't you? Unterminated token at the end of your text buffer cannot be accepted. That's what we wanted. Perfect. I think that means tools test permutations.py time I think that's it. Yeah, so far so good. How are you doing? What's new? It's been a couple of weeks, isn't it? So how's moving into your new home? It's starting to settle down, feel like home, starting to feel a little bit more natural. It's always a little odd at the beginning, but is that it? I don't want to start dancing a victory dance too early. It passed. Yes, so then should be able to do all the tests now, of which there are many. Lazy. We're putting lazy back in, and I really, so if dispatch equals dispatch go to, and if we're processing equals process lazy, continue. So hopefully this runs correctly. Oh, we'll see. Should be something like 24 full tests now, times 3 was 70. Well, and each, so that's, if I remember, there's 20 test cases. Is this really gonna hang? Tell me it's not hanging. Go to process lazy. Why is go to and lazy in the same thing? That shouldn't be possible. Go to and lazy. These should never be actually done. It's, oh, I haven't done lazy processing yet. I'm telling it, if dispatch is this and processing is this, don't do it. Don't do this part. Continue. Go to the next procedure or process. Oh, it's so infuriating. What is this line doing? I don't understand. Am I spelling something wrong? Nope. Continue. So should then proceed to batch. Dispatch and proc. How is this continue not going to the next process? I don't want to break. I want to hit batch next? I know lazy is not done. I haven't implemented it. I'm trying to skip it. This is Python equivalence, not like Java equivalence. This combination should never be possible. For each dispatch method, for each processing method, oh. If not, dispatch equals that. If dispatch equals and proc equals not, if we just change the logic around it, look at that. Goto and lazy. Why? This should be like the easiest part of the whole thing. Print. Dispatch. Process. Dispatch. Proc. If dispatch equals something and proc equals something, continue. Print. Skip. Nope. None of them had skipped. Goto and lazy. Right, I'm so confused. Oh. Oh, good heavens. I know what's going on, I think. Oh. Because of these combination ones. These aren't strings, these are arrays. I forgot about that. So if this is in dispatch and this is in proc, then we skip. All right, /test permutations. Hi. Now, that should do it. Oh, how am I doing? I'm apparently forgetting that I store arrays of arrays instead of arrays of text. But I think goto processing for batch processing is now implemented and working. Not sure why. I have that in that order. Oh well. Actually, what am I saying? Oh well. Let's. We want to know this order in text.cp. I want them to correlate. So we're going to do file IO. I don't care about that as much. It's kind of independent of everything else. So if we dispatch process, okay, so file IO is last. Then our helpers, then our okay, so we go dispatch first. We'll do process. And then our text generator, then our function pointer, which actually probably comes for text generator there. Okay, let's just see how we're doing. 30 tests in. All green, it looks like. Yeah, this is a bit more work here that we're doing. But I think we've got all the code paths working, and batch processing may just about be done. Whew. That's kind of crazy. I did not think I'd get it done in a day. How many tests are there now? $44? Are there 44 tests? Maybe there's more, I don't know. There we go, 132 successes. Ooh, journal. We did that. Add to automated tests. Automated tests, let's see here. Batch processing for goto dispatch method is now working. all tests are automated and pass. 132 out of 132. That's worth the celebration right there. Good heavens. It had everything correct. Go to batch processing. It's done. And automate and with automated testing. Oh, okay. Now, VV test parser. One thing you'll see is that the number of lines has kind of grown because we now implement these functions for our DFA states, but we also implemented up here with all the gotos. So up here, we re-implement basically the same code in slightly different context, I guess. So we have some duplication of code, and the sad part is we are going to duplicate that code again. Because when it comes to the lazy processing, it's going to have to go in here, right here. Oh man. But with all the considerations for laziness. Which means we are almost done with this step. Oops, don't. Now, this step, once completed, we can do some of these other tasks. So I'm thinking next week we'll do lazy. It's 5 o'clock. We still have an hour. We have these three. Automated testing. Yeah, we're almost at the point where we need to do this, which is going to be fun. This is a brain melty part. Yes, excellent. This is coming together nicely. Progress is being made. Do I want to grind on for an hour? Oh, well, we've got this done, actually. The different file reading methods are done. Test empty files against all encodings and all encodings and permutations. That may actually not be that hard because the test framework. We can maybe do that. We should be able to do that. So that happens to test permutations down high, down, oops, here. Oh no, it's in test.cpp. I think we want to do this. Empty string. White space only. White space and comment only. So regardless of anything else, CRLF. Should we try it? How brave are we? We believe. That takes 4.5 minutes to run the full suite of tests. And the first one to fail, we'll just kill it. And we'll do manual testing if we need to. Fail. Oh, no. I see. I know what's going on. All right, the automated test execution. Automated empty test execution. Or test expectations count one count tokens longest token len lines. And this thing takes expectations All right, we're going to start with defaults here. So, test expectations dot pair count equals 0. Warning count equals 0. Tokens equals 0. Longest token len 0. Lines equals 0 or 1? That's actually a good question. It's an empty file. It has one line. I don't know. It's probably 0. Most tests, this is what we're looking for. Okay. Okay. Line 2, 3. Yeah, so I would say it's probably 1, except where it's 2. And down here, expectations, expectations. Okay, now here, expectations dot error count equals 1. So we pass in those expectations. This one we expect 2, so I'm going to do this. We'll put it under the banner here, 2. Anytime we vary things for test. All right. I just want to know how close this comes to working. All right, time for bed. Have a good weekend. You too. You too. Nice work. Thanks. It's getting there. We just got to get the lazy processing done. That will be nice. Test. Shell. We don't have a shell. Why don't we have a shell? All right. /tools or cd rather. /test permutations. We're going to break out of that. All the testing. Great. We'll just see how that goes. See if we can improve our testing a little bit to take a structure of things we expect to happen in that run. Oh wow, it actually passed. Crazy. Oh my. Okay. So that works with empty files as well. All those expectations we had are correct. So guess we try it for realsies this time. That's about a 4.5-minute operation if everything goes well. If things don't go well, it may hang, it may be sad. That's, empty files. We should be able to see the output of some of this stuff in the log file as it's generated. Right about here. Empty string, whitespace only. Error, unterminated token. Oh, we need to get rid of that hint statement, which is in maybe project. Nope. Tokenizer. Right there. Context. I think there was one here as well. Actually, I do want that here. Oh, we don't need this actually. Twenty messages. Here's the message count. And then the last one, and then we fail. This is not the best, but whatever. Oh, we're failing. Uh-oh. There are some failures. Having to do with lazy processing. Okay. Always lazy. Expected one line got 0. So when we're lazy, we never add in that extra line. Or not. But whitespace only expects 2 and got 2. So empty, lazy, empty. That actually means we're really close. Lazy, start new token. Begin. Start new token, has token. Compute next token. Where's that trailing bit here? If we are done. Okay, so we never had a valid token. Because it's only the empty file that fails when we're lazy. UTF-8 character reference. What do I have? Do I have byte offset, char offset? I have char offset. So if, let's see here, else, if current dot char offset is equal to 0. So if there never was anything, then we do a new line and fail. I think that's the answer. Let's see how that goes. That's why we do testing. Testing an empty file is always good. CD tool, oh no. Tools dot slash test permutations. Oh, I cannot type apparently at the end of the day. There we go. All right, and the first lazy should show that we are correct, question mark. So gotos should all pass because they don't do lazy processing yet. Yeah, next week we'll do goto with lazy. Uh-oh. Something didn't build. Lazy. Failed to build. Is it what I just did to tokenizer? Oh. It's that. Try it again. All right, so we'll get our 4 gotos up front. Put things back to our default here. Batch. Good. Yeah, sure. That shouldn't affect anything. Oh, that still failed. On this command. Oh, I thought we fixed that. Okay. That's tokenizer. I did fix that. Yep. The more tests you put into a thing, the more likely it is to. Well, maybe not the more likely it is to be correct, but the more likely it is that you'll catch more of your own errors. Like looking for empty files. I did not think lazy would break on that, but you know, lazy is also probably the least exercised currently. That was the last one implemented for our processing methods. Batch was first. everything was kind of designed around batch. So all the exceptions that happened in lazy are little corner cases we just haven't found yet. Okay, that's working. Now we've got lazy working. Not bad. So that takes, what, 4.5 minutes, give or take. Ooh. Ooh. And while this is a toy tokenizer, like we're not using a lot of, we're not generating lots of different kinds of tokens. Test parser, reload. You know, it's 2,000 lines of code saved that you didn't have to write yourself. Process things in 132 different combinations. Yeah, no, I'm super excited for when we do the final performance test against, to see how close my intuitions are about what's faster than what. Ooh. More than halfway done. About 20 left. So far it all looks good. Dispatch process. Iterator helper file. Yeah. Our system is we're rotating through these file methods. We aren't actually testing against those files. That's what I meant in my to-do list. Testing for file reads. So blah blah blah. This one's in our, there we go. Testing for file reading. Those can be very small, easy tests, like just one test case. 10 more. We're 3/4 of the way there. Even though we added 3 tests per pass, still isn't taking all that long. Of course, an empty file should process quickly, one would hope. 40, we're at 4 more. 3. 2. 1 more after this. Last one. I think we've done it. Empty files now working. Woohoo! Empty file, whitespace file, whitespace commit files now being tested, and all pass 132 out of 132. Done. Empty and near empty files tested and working. Awesome, awesome. Hey, C Films. I'm doing great. How are you doing? I'm doing great. I just got my automated testing to pass all 132 build option combinations that we want to test, which is a little bit complicated, but it's working and everything's working. Our tokenizer is working, or our tokenizer generator is generating a working tokenizer for all these different build combinations. So there's 44 build combinations tested against 3 encodings each. That's 132 tests. What have you been up to, C Films? Haven't seen you in a while. What's your status? Sit rep, or I don't know. How do cool people talk about things? All right. So we need a test for loading a file. And all I care about is that the file is read and tokenized reasonably, which means it should only contain things. Nope. Empty string whitespace only, whitespace and comments. Yo. Let's see here. I don't know if I can. So, Yo Minega, how are you doing? Welcome. Thanks for the follow. Let me know if you have any questions or comments. We're building a compiler from scratch with no dependencies, and we're doing it all the wrong ways. Every way that people tell me I shouldn't, that's the way we're doing it. And also just my own experience. We're right now in the Tokenizer Generator phase. So we're writing code that'll take in a configuration which generates a tokenizer for us. A tokenizer can be very simple. If you handcraft it, it's just a loop through the characters. Make your decisions when you see the character. In this case, we are generating all of that code from a small pattern like test UTF-8 tokenizer. So here's a token name, the actions we should take when we get that token. So if we get a new line character, we should discard that token and then mark a new line. For whitespace, we discard. \s is a special character for UTF-8. So is \n. Comment, \, and then anything up to the new line. Int, obviously a bunch of digits appended together. But ours are a little bit different. Since we implemented our own regular expression engine, we are also handling UTF-8. So here's the Cyrillic alphabet for Russian and I think Mongolian and a few others. And then here's the Greek alphabet. We also support different encodings like Latin 1 and ASCII. And we're just generating out this file, which is 2,000 lines of parsing of a tokenizing code, which could be a lot simpler, a lot smaller. But every time I have an idea about performance, doing things one way or another way, I implement it both ways and put all of those branches inside these pound defines. So when I build, here it is. We can dispatch our DFA states using nothing but a function pointer, or maybe we use a function pointer array lookup, maybe we use a switch statement, or maybe we just use raw, unadulterated gotos to jump from state to state. We can iterate different ways. We have different methods for processing, whether we batch it all up and then you can ask for all of them at the end, or whether you can ask for one at a time. So batch versus lazy. whether things are implemented as macros or functions in some cases, how we're reading in our files. Those are all things that we test. And now all of these combinations and all of our supported encodings are passing the tests finally. So that's good. That makes me happy. So yeah, let me know if you have any questions. I'm happy to go into any level of detail if you want me to describe tokenizers or tokenizer generators or what our end goal is or whatever. Like happy to show code, talk details. Just let me know. Otherwise, we've been passing raw text to all of our tests and not loading a file. So the different file method opens aren't being tested for us. So let's see, here's our test, right? We say if we're testing ASCII, here's the test we're going to test against, and here's our expected outputs, right? We expect 5 tokens, we expect the longest one to be 8 characters, and we expect 3 lines of text with no errors. So we test against the text and make sure that the expectations match. But all of these, I'm handing in string literals, basically. This is probably actually a really bad way to do the testing, but you know, it's worked so far. Maybe we should be a little bit more strict. Text 1024. Maybe we should stir copy when we set text instead of using string literals in our assignments, which is not great. So we can do that. Search for text equals, comma, stir copy, parens. All right, we'll just make sure this all is properly copied. At the end of automated test execution, we don't have to delete anything. Yeah, that all seems fine. Okay, so that's good. So we need a test that loads a file and then tests from that. So let's rename this. Automated test with automated string test. Automated string test, automated file test. So instead of text, we're going to hand in the file name and our expectations. I think that's it. No, let's give it the label. We're going to be testing the label. In our context, we are not going to reference a text. We are going to read file. Then we get our tokenizer. We capture our outputs in a couple of different ways. Yeah, and then we just run all of that. Basically the same thing. Don't see any reason to reinvent the wheel. I mean, we could just pass a flag if we wanted to. That's starting to look more correct to me. All right, so our test has a configuration. Test expectations, struct test, config. And we need to know const char star text. We need to know const char star label. We would like to know boolean is file. Test config config.label config.text. And the only real difference here is if config.isFile, then we read file. Otherwise, we do that. That's basically the only real difference in the tests. However, we now need to make a test config. Config.text equals something. Config.label equals something. Config.isFile equals true to start with. This is our initial config. Empty file. Well, which means we can do the following. Config.text. Nope, I already don't like it. We're going to do this. Text 1024. Label, it doesn't really matter. Config.text. String copy config label. Empty string. Then we pass in our config. Whitespace only file. Whitespace and comment on the file. Text. We don't even really need to. Well, we'll get there. We'll get there. I'm thinking I don't want to do copies all over the place, so we'll change that. Config dot. So I'm going to change this. Stir copy config dot text. Okay, then we're going to do a little macro magic here. Search for end if. Okay, I don't want to do that. Search for end if kill 1, 2, 3, 4, 5 config stir copy config dot label whatever it was I stole, save F4. Boom, 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 boom. One more piece we want to do here. Like I said, I don't want to pass this stuff, so we're just going to pass in the pointer expectations dot expectations point to config dot with config point to 1, 2, 3, 4. Okay, we're getting close to where we want to be here. Except this be replaced with the address of these things. There we go. So now I can add a file open. Here on down, there'll be none of that. Okay. So now if we want to do file testing, it should be able to happen right there. Where are we at? We got a few minutes left. So yeah. The question is, where does this file come from? And I think the answer is permutations.py. And all we want is a minimal file that just kind of works, which means it can't be anything complicated. We're gonna with open temp dot VV test. I don't know. Write text as out file. Out file.write. Let's see here. We accept whitespace comments, token IDs. So let's get a token ID. Hello world \n 42. And we do handle strings. String. That's probably good enough, right? That should just kind of work. Maybe. Okay. File read, and then I also want to test for file not read. Error count, warning count, those can be 0. Number of tokens should be 1, 2, 3. Longest token length is 5, 5, or 1, 2, 3, 4, 5, 6, 7, 8. I think it's just 8 again. 8. We expect no errors, no warnings. Number of lines. I think we have 3. 1, 2, 3. Is file. So here's our config. Here's our expectations. This one, we expect 1 error at least. 0, 0, 0. Do this. And this. And the last piece is config dot store copy config dot text. We want VV test. Error. That should throw me 1 error and nothing should happen. Just out of curiosity. Okay, so we go to test permutations. We don't want to run this forever. So we'll break out early. And we'll try to run it again. If this all works, then we'll crank up the full test round. File exists, file doesn't exist. This should all, of course it doesn't work. Command. failed. CD source. What does the build look like? Text. Config label. Really? Oh, const. Why did I put const there? Good heavens. Okay, that's bad. What else do we have? Const start text no longer is a thing. Okay. Oops. That does make sense. 118. Expected to, oh, after the struct. Yeah. We can have more complex configuration and expectations now that we've got those put into structs. Okay, now we want to go run that again. I don't know. Yeah. We could test an empty file if we cared. Oh, stack dump. That's not good. Fail. Well, that's why we test, right? So out of curiosity, source builds debug db test. Testing something and it crashes. Curious. Config label. I did not put a label in here. Oops. My bad. Oh, good heavens. This is a read from file. Missing file. Oops, that did not build, so yeah, forget that. All right, we're close. Expanding testing, gotos in batch mode. Fail. Still dumping. Fail. Still dumping stack trace. That's unfortunate. Let's see. What is it? Temp.vv test. Oh. Tools. Temp.vv test. temp VV test. It's not there. Is it in source? It is. Well, shoot. Um, hmm. Okay, that should probably still fail. It should fail at a different place. Oh, it's still expected 3.4. Read from file. Oh, yeah, 4. Okay. Um, and we expect 4 tokens. Oof. It's been so long since I've done the file reading stuff. I don't remember how it responds to a missing file. I'm pretty sure it... Nope. Okay. Assets. Text buffer implementation. Read file. We have a file name. Report error function. See, I have no idea where in this it's crashing. But what? So if it reads the file, it's fine. If the file is not found, I thought we had error checking around that, like clear. If the file name is not found, if we couldn't open the sucker, let's see here, which file opening method were we even using? But all of these should report errors as well. Report error. Much the same stuff here. Huh. I thought I checked all the error conditions. So read file. Text and a label. This file is true, this file is false. If it is file, read the file, otherwise reference text. Oh. Read file. Read file, buffer read file. So if you fail to read the file and then it just keeps on cranking through here, that could very well end up in some bad states, like it even trying to parse things. Tokenizer set context. Okay, and then the things that need to happen, if we batch process, it should not. Tokenizer shouldn't do anything if there's already an error in it. If context dot if error count greater than 0, or is less than or equal to 0, then we can do all of this. Where we actually process it. Token count, token length, line count. I'm not sure what that's going to do. Buffer should return 0, so that may be okay. Error count, etc. Warning count. Let's just try it. And then we'll probably have to wrap it up, whether we got the missing file working or not. Basically, we don't want the... Okay. Command. Let's see where it fails. Int error count is a redeclaration. That's fair. 170. Oh, it's passing. It's passing. Cool. All right. Test permutations.py. Let's make sure that all the tests pass the empty or the file read and the missing file tests. So 4.5 minutes, then we're probably calling it a day right there. I didn't count it. want to time it. Because we're adding more tests. I wonder how much it actually affects things. If it's a lot more than 4.5 minutes now because of the couple of file tests or not. Unclear. Okay. Look at the log file real quick. Building the object files. There we go. Missing file could not find file error, which is the expected error, and therefore we pass. Yeah. Cool. All right. All of these things should reasonably work. Oh, thank goodness. Which may be a little bit of a premature celebration, but I figure if we're 9 or 10 tests in, unless there's a very strange combination, the file opening should not affect the tokenizer much. That's kind of true of the compiler. Each stage, the tokenizer, the parser, the semantic analysis, each stage should not proceed if there were actual errors in the previous stage. A warning you can ignore, right? You can try your best and pick defaults when needed, or resolution strategies of some sort. But an error, you should not proceed. So when we get an error at file read, we should not proceed then to the tokenizer actually doing anything. And my opinion is the tokenizer itself should assume you've done that check. I don't think it's on the tokenizer to verify that there are no errors. I think it's up to the overall flow. Because we're going to wrap all this up inside of a couple of nice functions. It's going to minimize a lot the user interaction with these things. So like in test.cpp, when we start up a test, you know, we read a file, we reference a text, we add it to the tokenizer, then we check for errors, and that all is going to be wrapped up into a couple of convenient functions in the end. A couple of nice clean interfaces. Right now it's all a little bit exposed, a little raw. Oh, but yeah, it looks like file tests are going to be good to go. To do test file reading, failed file reads. Those are doing it. So let's see here. Empty text, whitespace, text, text. Added basic file read tests. File exists, file does not exist. And we'll wait for all tests pass. 132, 132. We haven't seen it pass yet, but I assume it will. It's always encouraging. Oh, very good. Hey, we made it. Nice, and it's still 4 minutes, 31 seconds. Almost all of our time is spent compiling. Our tests are taking almost no time. We've added several tests today, and this has not varied much. So, good to go. I did not lie that we added those tests and that they all passed, so source temp. Hit ignore. We don't want VV test showing up here. VV test. Added tests for empty file and for read file and missing file. And our little testing thing is getting more and more useful. So, sweet. I think we're done for the day. We did get batch processing using goto methods, dispatch. Next week, we're going to do lazy processing with goto, and that will be all of our tests. That will be the whole shooting match, which probably explodes our test duration quite a bit, but that's important that we test all the possible combinations. As you can see from today, we found a number of issues with some different pieces because of that testing. So, we're looking good. Oh, we're almost to the fun mind-bendy parts. Yeah. So thanks for joining. You have a wonderful evening. Have a good weekend, and I'll see you on Monday back into game development mode. Thanks for joining up, and I'll see you next time. Bye-bye.